All right, ready to dive in. Today we're taking a deep dive into the world of Bryce DeWitt.
Oh, yeah, Bryce DeWitt.
A physicist who wasn't afraid to, tackle some of the most mind-boggling ideas in quantum mechanics.
Yeah.
And we're going to be looking at him through the lens of Yorgo Schneeppert, who wrote a fantastic piece on him.
Yeah.
So set the stage for us.
Okay.
What's so fascinating about this guy, DeWitt?
Well, DeWitt's story, it's a really fascinating one.
Yeah.
Schneeppert tells us that he started out at Harvard,
Okay.
already at a young age, showing a strong inclination towards theoretical physics,
Wow.
But then World War II erupted, which, interrupted his studies like so many others at the time.
Yeah, I mean, it's kind of hard to imagine, right, being pulled away from something that must have been so intellectually stimulating to then, face the realities of war.
Right.
So what did he do during the war?
Well, Schneeppert doesn't go into a lot of detail about that period. But like many brilliant minds of that era, he ended up contributing to the Manhattan Project.
Oh, wow.
Which, to say the least, must have been an intense experience.
Yeah.
Yeah.
Absolutely.
So
after the war, did he return to his studies?
He did, yeah. He went right back to Harvard to complete his PhD, and this is where things start to get really interesting.
Okay.
Because, according to Schneeppert, he studied under Julian Schwinger,
Wow.
a pioneer in quantum field theory, who would later go on to win the Nobel Prize for his work.
Talk about a mentor.
Yeah, right.
I mean, that must have just had a profound impact on his development as a physicist.
It definitely did. And Schneeppert, he points out that you can really see Schwinger's influence in DeWitt's dissertation,
Okay.
which focused on this really complex interaction between gravity and matter.
Okay.
Which, as we'll see, this theme kind of recurs throughout DeWitt's whole career.
So even in his early work, we're already seeing these hints of this fascination of connecting the very large gravity with the very small, the quantum world.
Exactly. And you know what really fueled that fascination was another really key figure in DeWitt's life.
Oh, okay.
John Archibald Wheeler.
Oh, wow.
Some people, you might know him as the guy who coined the term black hole.
Yeah.
And Schneeppert makes it very clear that his mentorship was crucial for DeWitt.
Wheeler, with his bold ideas about gravity and relativity.
Right.
He must just been the perfect, intellectual sparring partner for DeWitt.
Oh, absolutely. I think Schneeppert even suggests that Wheeler's influence is what really propelled DeWitt's deep dive into the connection between quantum mechanics and gravity.
So this kind of brings us to, I think, one of DeWitt's most notable contributions. Yeah. His work on the many worlds interpretation of quantum mechanics.
The many worlds, yeah.
It sounds like something straight out of science fiction.
It does.
Yeah.
It's a pretty radical concept. So Schneeppert explains that, DeWitt didn't actually come up with this idea originally. It was Hugh Everett III that first proposed it.
Okay.
But, DeWitt championed the idea. He refined it. And he kind of presented it to the world in a way that made physicists really sit up and take notice.
So for those of us who are not theoretical physicists, break this down for us.
Yeah.
What is the many worlds interpretation?
So, in essence, the many worlds interpretation suggests that every possible outcome of a quantum event actually happens.
Okay.
Just, it happens in a different universe.
Okay.
So, for every decision you make, for every coin you flip, for every, random event, there's another universe out there where a different outcome played out.
So there's a universe out there where I decided to become a professional astronaut instead of a podcast host.
Yeah.
That's wild.
It's a pretty mind-bending idea.
It is.
And, Schneeppert does a great job of explaining how DeWitt grappled with the implications of this concept.
Right.
Not just the math behind it, but...
It raises all sorts of questions, right?
Yeah.
About identity, free will, even the very nature of reality itself.
Absolutely.
It's a lot to wrap your head around.
It is.
Yeah.
And Schneeppert, he points out one of the key things that DeWitt wrestled with was how do these parallel universes interact?
Oh, right.
Or rather, how do they not interact?
Right.
And this is where this concept of decoherence comes in.
Decoherence.
Yeah.
Okay. I think I'm going to need a little help with that one.
Okay. So imagine, a drop of ink spreading in a glass of water. Oh. As the ink kind of disperses, it becomes less and less distinct from the water. Mm-hmm. DeWitt, building on the work of others, argued that something similar happens with these parallel universes.
Okay.
They kind of branch off from each other.
Okay.
But their interaction becomes so faint.
That they essentially exist independently.
So it's not like we're bumping into our alternate selves on the street.
No, no.
Okay, that makes me feel a little bit better.
Yeah.
But I'm still trying to grasp the scale of this. It's talking about, like, a potentially infinite number of universes all existing at the same time.
That's the implication of the many worlds interpretation, yeah.
Yeah.
And it's one of the reasons why it's been both so fascinating and so controversial within the physics community.
Oh, for sure.
Yeah.
I mean, it definitely makes you question everything you thought you knew about reality.
Yeah.
But DeWitt didn't stop there, did he?
He did not.
Schneppet mentions something called the Wheeler-DeWitt equation.
Yeah.
What was that all about?
Ah, yes.
Yeah.
The Wheeler-DeWitt equation.
Okay.
This was a monumental effort
Yeah.
by DeWitt and his mentor, John Wheeler, to try and tackle one of the biggest challenges in physics, quantizing gravity. Okay, quantizing gravity. What does that even mean?
It means trying to essentially unify the laws of quantum mechanics, which govern, the world of the very small atoms, particles, all that, with the laws of general relativity, which describes gravity and the large-scale structure of the universe.
Okay.
So it's about trying to find this single framework that can explain both realms.
So they were essentially trying to find a theory of everything.
They were, yeah.
That's incredibly ambitious.
It is, and it's, it's still one of the holy grails of modern physics.
Oh.
And, the Wheeler-DeWitt equation was a big step in that direction.
So what did the equation actually do? How did it try to bridge this gap between quantum mechanics and gravity?
Well, Schneppet explains it as a mathematical attempt to describe the wave function of the entire universe.
The wave function of the entire universe?
Yeah.
Okay, I'm officially lost.
Okay, so think of it this way.
Okay.
So in quantum mechanics, a wave function describes, the probabilities of different outcomes.
Right, for a particle.
Yeah.
So the Wheeler-DeWitt equation, it attempts to do the same thing.
Okay.
But for the universe as a whole. It's a way of describing all the possible configurations of space, time, and matter.
So this one equation
tries
to encompass all the possibilities of the entire universe.
It's mind-boggling, to say the least.
I don't even have words.
Yeah, that's incredible.
But it's important to remember that, the Wheeler-DeWitt equation wasn't a complete solution.
Okay.
In fact, Schneppet points out it kind of raised as many questions as it answered, particularly when it came to the nature of time.
Okay.
But it was and still is a crucial stepping stone in our quest to understand the universe at its most fundamental level.
Yeah, you see, one of the biggest puzzles that kind of came out of the Wheeler-DeWitt equation was the question of time.
Oh, okay.
So in general relativity, time is woven into the very fabric of space-time.
Right.
But in quantum mechanics, time is treated as this kind of external absolute parameter.
And so the equations seem to suggest that at the universe's, most fundamental level, time may not exist in the way that we, typically understand it.
So are we saying that time is an illusion?
Well, it's a pretty radical idea, right? And it's, something that physicists are still grappling with today.
Yeah.
Schneppet doesn't really, delve too deeply into the, philosophical ramifications of this, but it's certainly a tantalizing thought.
It is.
Yeah.
So, okay, we've talked about the many worlds interpretation.
Right.
We've talked about the Wheeler-DeWitt equation.
Right.
What kind of impact did these ideas have on, the world of physics? Did they just remain these abstract theories? Or did they have practical implications?
Well, I think Schneppet really emphasizes that DeWitt wasn't just some theoretical physicist, lost in abstract thought.
Yeah.
He was deeply interested in how these ideas could be applied to the real world.
Okay.
Particularly in the realm of technology.
It's always so fascinating to see how, theoretical physics, which can seem so far removed from our everyday lives, ends up shaping the technology they use.
Oh, yeah. It's incredible.
Yeah.
And, DeWitt's work is a great example of that.
Yeah.
Schneppet points out that, DeWitt's insights into quantum field theory really laid the groundwork for advancements in fields like quantum computing.
Quantum computing. That's one of those buzzwords that we hear a lot these days.
Right.
Could you give us a, quick rundown of what that's all about and how DeWitt's work played a role?
Sure.
Yeah.
So quantum computing basically harnesses the strange principles of quantum mechanics to kind of perform calculations in a fundamentally different way than traditional computers.
Right.
It has the potential to, really revolutionize fields like medicine, materials science, artificial intelligence.
Yeah.
By solving problems that are currently just intractable for even the most powerful supercomputers. And DeWitt's work on quantum field theory,
right,
provided some of those theoretical building blocks that really made these advancements possible.
So even though he wasn't directly building quantum computers,
right,
his work provided that foundation.
Absolutely.
Upon which others could build.
Yeah, it really highlights how that fundamental theoretical research can have these far-reaching practical consequences, often in ways that are, hard to predict at the time.
It's a good reminder that investing in basic science is essential for driving technological progress, right?
Oh, absolutely.
Okay. Now, Schneppat also mentions DeWitt's influence on cryptography.
Cryptography, yeah.
What's the connection there?
So this goes back to the many worlds interpretation.
Okay.
And its emphasis on the kind of inherent randomness of quantum events.
Okay.
So this randomness, according to Schneppat, can be exploited to create these incredibly secure encryption methods.
So we're talking about the kind of encryption that could safeguard sensitive data even in the face of really sophisticated cyber attacks.
Yeah, exactly. Okay. Quantum cryptography, as it's called, has the potential to really revolutionize data security and protect privacy in this increasingly interconnected world.
It sounds like something straight out of a spy thriller.
Yeah, it does.
But it's amazing to think that these futuristic sounding technologies have their roots in the theoretical musings of physicists like DeWitt.
It is, yeah.
Yeah.
And Schneppat also highlights another area where DeWitt's work has had a big impact,
right,
the development of these highly sensitive sensors.
Yeah.
How do those tie into the world of, quantum mechanics and the many worlds interpretation?
So it's not so much about the many worlds interpretation itself, as it is, about DeWitt's just deep understanding of quantum phenomena.
Right.
And his work really helped pave the way for the development of sensors
that are capable of detecting these incredibly faint signals down to the level of individual atoms or photons.
So we're talking about applications in medicine, where we need to detect minute changes in the body, or astronomy.
Exactly.
Where we're trying to pick up signals from distant galaxies.
Yeah.
Wow.
These sensors have the potential to, unlock all these new discoveries and advancements across a wide range of disciplines.
It's amazing to think that DeWitt's work, which started with these, abstract theoretical explorations, has had such a tangible impact on the world around us.
It really is.
Yeah.
And I think it speaks to the power of scientific curiosity and the importance of pursuing knowledge, for its own sake. You never know where those pursuits might lead you.
So Schneppat does a fantastic job of conveying not just, DeWitt's brilliance as a physicist, but also his ability to inspire others.
Yeah.
He mentored numerous students and colleagues who went on to, make their own significant contributions to science.
Yeah.
What was it about DeWitt that made him such an effective mentor?
Well, Schneppat really portrays DeWitt as someone who was not only brilliant, but also incredibly generous with his, time and knowledge. He was known for his, enthusiasm, his patience, and his ability to explain complex ideas in a really, clear and accessible way.
Right.
He wanted to share his passion for physics with others and really encourage them to explore the mysteries of the universe.
It sounds like he had a real knack for making even the most intimidating concepts, approachable.
Oh, he did, yeah. It's a valuable skill for any teacher, especially when you're dealing with something as complex as, quantum mechanics.
Yeah.
Schneppat, I think, judging by his ability to explain DeWitt's work, in such an engaging and understandable way, seems to have inherited that from him.
It's true. Reading Schneppat's essay is like having, a personal tutor guide you through this intricate world of theoretical physics.
Exactly.
He manages to make it both intellectually stimulating and genuinely enjoyable.
Exactly. He really captures both the, the intellectual rigor and the sheer wonder of DeWitt's work.
And that sense of wonder is something that I think we often lose sight of.
Yeah.
Especially, as we get older. And perhaps more cynical.
Yeah.
DeWitt, by all accounts, never lost that, childlike curiosity. That drive to understand the fundamental nature of reality.
Yeah, he never allowed himself to become jaded.
Right.
He always approached the universe with this sense of awe and excitement.
Right.
And he really encouraged others to do the same.
Yeah, it's inspiring to think that, like, one person's passion for understanding the universe can have such a ripple effect, right? Influencing not just scientific progress, but also, like, the way we think about our place in the cosmos.
Absolutely. It's a testament to the power of ideas and the enduring legacy of those who really dare to push the boundaries of human knowledge.
Schneppat, he leaves us with a really thought-provoking question at the end of his essay.
Okay.
What mysteries are still out there?
Yeah.
Hidden in the fabric of the cosmos, just waiting for, someone with DeWitt's spirit to uncover them.
It's a question that I think should ignite the imagination of, anyone who's ever looked up at the night sky.
Right.
And just wondered about the vastness of it all.
Yeah.
Yeah.
It makes you realize that we're still just scratching the surface, right?
Oh, yeah.
Of understanding the universe.
Absolutely.
There's so much more to explore.
Right.
So many more questions to ask.
And that's the beauty of science, isn't it?
Yeah.
It's this, like, never-ending journey, this quest for knowledge.
Yeah.
That's driven by curiosity and a thirst for understanding.
So to all our listeners out there, thank you for joining us on this deep dive into the life and work of Bryce DeWitt.
Bryce DeWitt, what a guy.
We hope you've gained, a new appreciation for the power of theoretical physics.
Yeah.
And the profound impact it can have on our understanding of the universe and ourselves.
Yeah. And if you're ever feeling lost or uncertain about the direction of your own life, just remember those words of Schneppat, where he reminds us that the universe is a vast and mysterious place full of wonder and possibility.
Keep exploring, keep questioning, keep that spark of curiosity burning bright.
Couldn't have said it better myself.